Hello! Welcome to today's lesson on direct current, DC, and alternating current, AC. Today, we will understand the differences between direct current, DC, and alternating current, AC. We will then compare the visual representation of DC and AC using graphs. Let's get started. Before we dive into the specifics of DC and AC, let's quickly recap what electric current is. Electric current is simply the flow of electric charge through a conductor, like a wire. This flow is driven by a potential difference or voltage between 2 points. Let's start with direct current, or DC for short. DC is the type of current where the electric charge flows in one direction only. This unidirectional flow is caused by a direct potential difference. Direct potential difference is characterized by its consistency. It maintains a constant magnitude or size and direction over time. This direct potential difference creates a push that drives electrons through the circuit in a single constant direction. This continuous unidirectional flow of electrical current is what we call direct current. Common sources of direct potential difference are batteries, which provide a stable voltage output that doesn't fluctuate. For instance, a 9V battery consistently delivers 9 volts as long as it has a charge. Because the current flows in only one direction, DC is ideal for low voltage applications and for devices that need a stable and consistent voltage, like your phone or laptop when charging. Now, let's move on to alternating current, or AC. Unlike DC, in AC, the electric charge doesn't flow in just one direction. Instead, it rapidly changes direction, typically many times per second. This happens because of an alternating potential difference. The potential difference periodically reverses direction, causing the voltage to alternate between positive and negative values, pushing and pulling the electrons back and forth. This periodic change results in an alternating current, AC, where the current constantly changes direction, flowing one way and then the opposite way. This constant change in direction makes AC ideal for transmitting electricity over long distances, as it can easily be transformed to higher or lower voltages using a transformer. This flexibility is why AC is the standard for household power supplies. The electricity that powers your home is AC. In the UK mains, electricity is alternating current that changes direction 50 times per second, a rate we refer to as 50 Hz. To visually grasp the difference between direct and alternating potential difference, we can use graphs. Looking at this graph, the DC supply is represented by a straight horizontal line. This shows that the voltage remains constant over time. There are no fluctuations, just a steady 6V that pushes the current in the same direction continuously. AC, on the other hand, appears as a wave, which rises and falls, crossing the 0V line as it oscillates. This means that the voltage in an AC circuit is constantly varying between positive and negative values, indicating regular changes in direction and magnitude over time. One thing to note is that the peak AC potential difference on the graph is a little higher than 6V. This higher peak compensates for the times when the potential difference is close to zero. As a result, a 6V AC supply and a 6V DC supply will light the same lamp equally brightly. Even though the AC voltage fluctuates, the peak voltage ensures that the overall energy supplied over time matches that of the DC voltage. In today's lesson, we examine the differences between direct and alternating potential difference. We discussed how direct potential difference, commonly produced by batteries, maintains a constant direction and magnitude, supplying a steady flow of current. In contrast, alternating potential difference, often generated by power stations, changes direction periodically, resulting in an alternating current. Understanding these differences helps us appreciate their specific uses and the role they play in powering various electrical devices and systems in our daily lives.